Greetings, math wizards and champions. Today we're going to be talking about factors, which I think are fun. I guess that brings me to our first question. What is a factor? So a factor is a number or quantity that when multiplied with another produces a given number or expression. That seems pretty confusing. So in other words, factors are numbers that fit into other numbers without needing any decimals or remainders in their answer. So in other words, factors fit nice and snug into the numbers that they are a factor of. If I was to say 2 times 3 equals 6, we know that 2 and 3 are factors of 6 because they're going to go evenly into 6. Multiplication and division are inverse functions, which means they can undo each other. We know that 2 times 3 equals 6, so we'll know that dividing 6 by 3 will give us 2, or dividing 6 by 2 will give us 3. We can kind of go back and forth. That's the fun thing about math, is it will never change. So we know 2 and 3 are factors of 6, but they're not the only factors of 6. Numbers can have many factors. Let's try to think about what the other factors of 6 could be. We already have 2 and 3 listed. What are some other numbers that evenly fit into 6? Take a moment to think about this. So that's kind of a tricky question, but if you said 1 or 6 were your answers, you would be correct. 1 goes evenly into 6 times, and 6 goes evenly into 6 one time. A general rule of thumb is that 1 is a factor of every whole number, and every whole number is a factor of itself. Every number goes into itself exactly one time. 5 goes into 5 one time. 100 goes into 100 one time. 10 billion goes into 10 billion one time. 10 bajillion bajillion goes into 10 bajillion bajillion. You guessed it, one time.
A bajillion isn't a number, but you get the point.
Our next question that we encounter is how do we find and list all of the specific factors of a certain number? Go ahead and use the number 12 as our first example. The very best way to start finding factors is to start at the very beginning, the very first whole number, 1.
A general rule of thumb is
That 1 is a factor of every whole number, so we'll always start by writing 1, comma, because after our comma will come our second factor. We'll then work our way up the number line to see if every number in between 1 and 12 fits into 12 evenly and is a factor of 12. After 1, we'll see if 2 is a factor of the number 12. Another general rule of thumb is that 2 is a factor of every even number because it goes into every even number evenly. Think about it. If you list every number up to infinity going by 2's, it's all the even numbers. 2 goes into every even number evenly. So yes, 2 would be a factor of 12. The next number that we bring into question is 3. Does 3 go evenly into 12? It certainly does. 3 goes into 12 4 times. So we know that 3 times 4 equals 12. That way we know that 3 and 4 are factors of 12.
after 4 is
5, which we know does not go into 12 evenly. 5 goes into numbers that end with 0 and 5 evenly.
what?
What about the number 6? Does 6 go into 12 evenly? It does, 2 times. We know 2 times 6 equals 12, so we know to list 6 as our next factor. What about 7? No. 8? 8 doesn't go into 12 evenly. 9? No. 10? No. 11? Of course not. 12? 12 does go into 12 evenly. You guessed it, one time. So now we have all of our factors of 12. We have 1, 2, 3, 4, 6, and 12. So all of those numbers are going to be listed as our factors of 12 with a comma in between every number.
All of those are
Factors of 12 because those are the numbers that go into 12 evenly. To see if 3 is a factor of any given number, I like to use a trick that I was taught by a teacher back in grade school. She was a scary nun, and not only did her scariness stick with me, but this rule has stuck with me as well and it's been pretty helpful in most of my math classes, even in college. Well, if we want to see if 3 is a factor of any given number, or if 3 goes into any given number evenly, what we do is we add up the digits in that specific number. So let's start with the example of 12. We add up the digits in 12, which are 1 and 2. 1 plus 2 equals 3. 3 goes evenly into 3, so we know that 3 is going to go evenly into 12. Let's try a harder number. What about 75? Is 3 going to go into the number 75 evenly? We add up the digits, 7 and 5, which is 12. We know that 3 goes evenly into 12, so we know that 3 is going to evenly go into 75. In other words, 3 is a factor of 75. Let's try one more harder number. Let's try the number 106. We'll add up the digits in the number 106. 1 plus 0 plus 6 is going to give us 7. Does 3 go into 7 evenly? No, because we're going to have a remainder of 1. So we know that 3 is not going to be a factor, and it's not going to go evenly into the number 106. Just to recap some of the rules of finding factors, remember we always start at the number 1. 1 goes into every whole number evenly, so 1 is going to always be a factor. Every number is going to be a factor of itself because every number goes into itself evenly. So 25 is going to be a factor of 25. A billion is going to be a factor of a billion. 2 is going to be a factor of 2. That's just how it goes. Also, we know that 2 goes into every even number, so every even number is going to have a factor of 2. 2 is going to be a factor of every even number. We went over our rule of 3, so you add up the digits. So if it's a pretty long number, instead of just going to a calculator, you can just add up the digits, and if what you added up in that answer is divisible by 3, you know that that number is going to have a factor of 3. 3 will go into that number evenly. I'm going to end our lesson by going over a few examples of factors and how we can find the factors of these numbers. We'll start with the number 24, then we'll find the factors of 50, and finally the factors of 105. So you can see the numbers progressively get bigger and a little bit harder to find the factors of. Let's start with our first example, the number 24. In order to find all of the factors of the number 24, what we're going to do is list out all of the multiplication problems that result in an answer of 24. So as I said before, we always start with the number 1. What times 1 equals 24? You guessed it, 1 times 24 equals 24. So we know that 1 and 24 are our first two factors that we have found for the number 24. Next up, we think about the number 2. Like I said, 2 goes into every even number evenly. So 2 is a factor of every even number. 24 is an even number, so we know 2 is a factor of it. How many times does 2 go into 24? 12 times. 2 times 12 equals 24. So we know 2 and 12 are factors of the number 24. We come to think about 3. Is 3 a factor of the number 24? Let's use that little trick that I taught you earlier to see if 3 goes into 24 evenly. We'll add up the digits in 24, 2 plus 4. That gives us 6. And we know that 3 goes into 6 evenly, so 3 will be a factor of 24. How many times does 3 go into 24? 24 divided by 3 is 8. So we know that 3 times 8 is 24. There we have our next two factors, 3 and 8. What about the number 4? Does 4 go into 24 evenly? It does, 6 times. 4 times 6 is 24. So we know that 4 and 6 are going to be factors of 24 as well. Continue to count up. We know that 4 is a factor. We know 5 is not a factor because 5 does not go evenly into 24, so we will not list it as a factor. We knew that 4 times 6 is 24, so we already have 6 listed as a factor. But what about 7? 7 does not go evenly into 24, neither does 9. I skipped 8 because we know that 3 times 8 is 24, and we already have it listed. 9 does not go into 24 evenly, neither does 10 or 11. But you know 12 does go evenly into 24. We know that 12 is half of 24, so 12 times 2, which we already have listed, so we don't need to list 12 again. And after that halfway point, any number after that 13, 14, 15. Anytime we multiply that times a number, it's going to give you a number larger than 24. So we know that any number after the halfway point is not going to be a factor, except, if you remembered, the number itself. So after the halfway point, we'll stop, but we'll also list the number itself, which we should already have listed because we have 1 times 24. So we know that 24 is a factor of itself. So our final step would be to list out all of the numbers that were in our multiplications problems, starting from the least going to the biggest. So 1, 2, 3, 4, 6, 8, 12, and 24 are going to be our numbers that we list as factors of 24. All of those numbers go evenly into the number 24. Answer should look like this. The factors of 24 equal 1, 2, 3, 4, 6, 8, 12, 24. No comma. Now let's go to our next example, the number 50. We're going to start like we did last time. Start with the number 1. What times 1 equals 50? 1 times 50 equals 50. So we have our first two factors. Next up, is 50 an even number? It is. It ends with 0. So we know that 2 is going to go evenly into 50. How many times? 25 times. 2 times 25 equals 50. So we have 1, 2, 25, and 50 so far as our factors of 25. What about 3? Does 3 go into 50 evenly? Let's go ahead and use that trick that I taught us. So we're going to add up the digits in 50, so 5 plus 0, and that gives us 5. 3 does not go into 5 evenly, so we know 3 is not a factor of the number 50. What about 4? 4 does not go evenly into the number 50, but what about 5? 5 does go evenly into the number 50. 5 goes evenly into every number that ends with 0 and 5. 5 times 10 equals 50, so we know 5 and 10 are factors of the number 50. There are no other multiplication problems of whole numbers that will result in the number 50, so we know that we have all of our factors listed. So we would list them 1, 2, 5, 10, 25, and 50. All of those are the whole numbers that will evenly go into the number 50. All of them are the factors of 50. Last example is the number 105. It's quite a big number. So there's really two ways to find all of the factors without having to do too much math in your head. And that is to use a calculator, or you can use long division. So what we're going to do is find all of the numbers that go into 105 evenly. So go ahead and take a few moments to try to think of all of the numbers and all of the multiplication problems that result in the number 105. Then list all of those factors in numerical order going from least to greatest. Take a minute or two to try to think of this problem. After a bit of trial and error, you should have found that these multiplication problems result in the answer of 105. 1 times 105, 3 times 35, 5 times 21, and 7 times 15. All of those digits, all of those numbers are going to be factors of 105. So we list them from least to greatest. 1, 3, 5, 7, 15, 21, 35, 105. All of those numbers evenly go into the number 105, meaning they are all factors of the number 105. Factors will continue to be talked about and expanded upon. They'll continue to get harder the further along in math that you go. And so one day you'll be asked to factor an expression like x squared plus 4x plus 3. That's when you get to algebra. So that's more, it's a lot further down the line. And for my next video, which we'll be talking about greatest common factors.